Welcome back to the parent effect. We are looking at the binomial expansion today, which is really just a fancy formula that helps you to expand binomials, which means it is two terms, whenever the n gets so big that it becomes tedious to do it the other way. So obviously you guys would be comfortable going x plus 2 squared and manually doing that, but whenever it gets to the power of 4 or 5 or 6, it's going to become really, really tedious. And so luckily we have this formula, which is on your formula sheet, that is going to help you to do it. It's just a reminder that this terminology here is when you're going to use the C button on your calculator. So that's going to be NC1, NC2, NC3. It's just going through the different parts of the formula. If we just randomly choose a question, let's say we were asked to expand that, then this 2x would become a and would be put in here, 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 and here. And the 7 would be b, so that would start occurring here. You can see it's going up by one more each time. And the n is the 5, and that would go here. And also in these little bits here. Okay, so you're really just substituting into a formula. There is an end point. The end point occurs when it's 7 to the power of 5. You won't keep going, but in the Cambridge exams, you'll find that they usually ask you to just find the first 2 or 3, so you don't have to usually do the whole thing anyway. So in saying that, let's have a look at an actual example. And I've chosen a -1 simply because it's really common for people to make a mistake with that. So your first method mark's going to be obtained by substituting into the formula, and then you're going to get accuracy marks for using the formula correctly. So as we said before, this is going to be A, so A is 3. The B is going to be all of this. Okay, so B is -2x, and N is, of course, 5. So if we start off noticing, first of all, that we just want the first 4 terms. So that first one there is going to be A, and it's to the power of n, which is 5. So 3 to the power of 5. That would be the first term. The next one, we're going to be doing 5c1. We're going to be timesing by A to the power of n minus 1. So A is 3, and n minus 1 is going to be 4. So you're going to notice that this is going to go down by 1 each time. So there's lots of nice patterns to help ensure that you're doing it correctly. Now we didn't have B in this first term, so B pops in for the first time here, and it's all of that, okay? So it includes the x, and that's going to be just to the power of 1 at that point. You'll notice that these will always add to that number, okay? So if it's not, you've done something wrong. So if we go to the next one, we're looking at this one now. It's 5c2. We're going to be timesing by A to the power of, this time it's n minus 2, so 5 minus 2 is 3. So you see that nice pattern, 5, 5, 4, 3. And the next one, we're now squaring it, and see the 3 plus 2 is 5. So there's lots of nice patterns. So you should be able to just do the next one without almost even looking at it, because it's gone 5, 4, 3. So this is going to be 2, and -2x is going to be to the power of 3, because that's gone 1, 2, 3. And they only wanted 4 terms. So these are your 4 terms here, 1, 2, 3, 4. So you're going to get a method mark for writing that. And then the next marks are allocated for accuracy. So you're just going to be going 3 to the power of 5 is your first one. So we've got 243. And just remembering on your calculator, the 5CR is this button underneath the AC. So you're going to go shift like that. And that will give you what the number is. I usually do this nice and slowly to try and avoid making mistakes. I'm going to do 3 to the power of 4, which is 81. And then it's timesing by -2x, because when I do that to the power of 1, nothing happens. Going on to 5c2, which I think is 10. Yeah, so we've got 10, 3 to the power of 3 is 27. Just be really careful with the negatives here. We've got a negative and we're doing to the power of 2. So negative 2 squared is going to be positive and the x will also be squared. So this is probably the most common mistake. We don't do that so accurately. And the next one, we're doing 5c3, which is also 10. 3 squared is 9. Negative 2 to the power of 3 this time is going to be negative 8 x cubed. So just be really careful with that. If you're doing it on your calculator, you're putting brackets around the negative 2 and then to the power of 3. Okay, and that will make sure that if it's an even power, that it will be positive. And then you're just going to tidy that up. So we've got 243 here. We've got your 5 times your 81 times your negative 2. And you'll have your x in there. And then the next one, keep clicking the wrong button, is 10 times 27 times 4 this time. So 1080, but it's x squared. And lastly, we have got 10 times 9 times negative 8. So we're going to have negative 720. And again, you'll notice the pattern. It's going positive, negative, positive, negative. Okay, so lots of nice patterns. Just take it slowly and try to be as accurate as possible. And just make sure you keep those brackets to help remember to square both elements of this. Don't forget to like and subscribe.